We're going to calculate the probability with disjoint events. Another way to describe this type of event is mutually exclusive events. Disjoint and mutually exclusive mean the same thing. So let's dive into the example and you'll see what I mean. We're going to look at the example of rolling one die. Just to remind you, if you have two of these things called dies, we call them dice. But when you just have one, we call it a die, just so that you're clear on what a die is. A standard die has 6 sides, 1, 2, 3, 4, 5, and 6. If we want to calculate the probability of getting a 5 or an even number, I want to point out that a 5 is not an even number, and even numbers are not 5s. So what that means is that these guys are mutually exclusive. If you get a 5, you have not gotten an even number, and if you get an even number, you could not have gotten a 5. It turns out that calculating the probability of these guys is rather straightforward. We're going to look at doing it in 2 ways. We're going to look at calculating this using a formula and also using a Venn diagram. So let's go ahead and take a look at what the Venn diagram looks like for this situation. Venn diagrams usually have circles that represent events. And in the case of a disjoint or mutually exclusive events, the circles do not overlap. In other words, they have no outcomes in common. One thing I am going to do is I'm going to go ahead and label this first circle as 5. This will be the event where I show all the possible outcomes related to 5. And then over here, this circle will represent the event that you get an even number. And again, I'll put all the possible outcomes that you get for an even number. So in the circle where we get a 5, well, the one possible outcome is a 5. In the circle where we get an even number, we can get either a 2 or a 4 or a 6. Now some of you may be wondering, well, what about this big rectangle? It's important to draw it. A lot of times people refer to this rectangle as the universe. And the universe includes all possible outcomes, even ones that are not in the events that we're interested in. In the case of rolling one die, there are still some other possible outcomes, including getting the number 1 or the number 3. So we'll put them out here in this rectangle. And now that I've written all the different possible outcomes, I can actually use the Venn diagram to compute the probability. But we're going to look at this in a couple different ways. First, we're going to try it over here with this equation. We're going to, by the way, if we have the probability of a 5 or something else, probability of something or something, what we do is we usually turn that into an addition problem. So probability of getting a 5 plus the probability of getting an even is the same as probability of getting 5 or an even number. So I'd like to point out that if you are getting the probability of something or something else, we're going to add. And I'm going to contrast that and compare that to the probability of getting something and something. And when we did that, we then multiplied, right? So now we're adding because we have this or that. Well, anyways, let's go ahead and calculate the actual probabilities. So probability of getting a 5, well, there's one way you can get a 5, and there's 6 possible outcomes on the die. So that means that 1 over 6 is the probability of getting a 5. And then we will add to that the probability of getting an even number. Well, getting an even number means we get either a 2, 4, or 6. That's 3 ways out of 6 total. So we'll go ahead and we'll do 3 over 6. Now, what I'd like to point out is that many of you are going to try to take shortcuts, and you're going to go directly to the reduced fraction. Don't do that. I strongly recommend that you write out the actual number of outcomes that you know of first and reduce later. In this case, we know there's 3 even numbers and we know there's 6 total possible outcomes. So I write the 3 even numbers over the 6 outcomes. It's going to be especially important if you do this with cards because we've got numbers like 52 and 26 and 13, and it's not always obvious where the fractions come from if you write it out in reduced fractions. Okay, enough preaching on that. We're going to go ahead and add 1 6 plus 3 6. We get 4 6. Now we can reduce. That gets us 2/3. And then we could go ahead and use our calculator to get a decimal, which that turns out to be about 0.67, or we could write it out as a percent, which is 67%. Again, I'll remind you that probability is always a number between 0 and 1, so it can be written as a fraction, a decimal, or a percent. Now, one other thing I'd like to show you is how we can use the Venn diagram to calculate this very same probability. What we see is this. We're looking to find the probability of getting either a 5 or an even number. And we just count. If with a Venn diagram, there's 1, 2, 3, 4 ways to get a 5 or an even number, and there's 6 total possible outcomes. So from the Venn diagram, we go directly to 4 over 6, which again we could reduce to 2/3, and then we could always rewrite as a decimal as 0.67. Same exact result, same math, except here's a formula and here's a Venn diagram. Now, one last thing that I want to share with you is how to generalize. In general, we're going to have a formula that says if we have the probability of A or B, and we want to figure out what that is, it's just going to be the probability of A plus the probability of B. Now, one little rule that you need to know associated with this is only true if we have disjoint or mutually exclusive events. We'll take a look in another video at what happens if we have overlapping events. And there we will also have the probability of A or B, but our formula looks a little different.